All right, so here is our base I exploding dot machine. So this comes from just, well, saying, okay, we want to have a base I. So we just set up our exploding dot machine, and we know that the boxes have to be worth, well, 1, I squared, I cubed, I to the fourth, and so on. And we know the property that, well, I squared is equal to -1, but then I cubed is just I squared times I, which is -I, and then I to the fourth. Well, that's equal to I squared times I squared, or -1 times -1, which is 1. So we had this repeated pattern. So we can set up our base I exploding dot machine as a circular exploding dot machine, right? That goes 1, I, -1, I. So let's say we wanted to do this problem here. Let's say we wanted to go ahead and divide 7 divided by 1 minus 2i. So these could be considered Gaussian integers. What is a Gaussian integer? Well, that is just in the form of a plus bi, right? So we know that a complex number is in the form a plus bi, right? That's we're just, a and b are your real numbers, and then I is equal to, well, the square root of -1. So you have a real part plus an imaginary part. A Gaussian integer is also in the form a plus bi, but a and b now have to be integers. That's it, okay? So 7 is a Gaussian integer. That's just 7 plus 0i. And 1 minus 2i, well, that's 1 plus a -2 times I. So yes, we have two Gaussian integers here. Now to go ahead and to do this division problem, well, let's go ahead and put in 7 into our machine here. So 7 just looks like 7 dots, all in the ones, right? 1, 2, 3, 4, 5, 6, 7. There's 7. Now I want to divide by 1 minus 2i. So what does that mean? Well, that means I'm looking for groups of 1 minus 2i. So what does 1 minus 2i look like? Well, that's 1, and then I have minus 2 i's. Minus 2 i's. So I have 1 minus 2 i's. So it looks like I have 1 dot and then 2 anti-dots, or not 2, well, okay, I could have 2 anti-dots in the i's, but there's a property that says that anytime I have an anti-dot, I can always replace that with a dot in the kitty corner box, right? Because an anti-dot in I is the same thing as a dot in -I. So 1 minus 2i, again, I could have 1 dot and 2 anti-dots, but you never really need anti-dots in this machine because any anti-dot could always be replaced by a dot in the kitty corner box, right? Okay, so we have, this is 1, again, this is 1, again, I, -1, I. So we have 1 minus 2i. So it looks like 1 dot next to 2 dots going, I guess, in the counterclockwise direction. Okay. So looking at, our picture here, right now we don't see any 1 dot next to 2 dots. Okay, but we want 1 dot next to 2 dots. So let's go ahead and put it in. Let's put in, we have a dot here. We want 2 dots in our -I. But if I did this, I have to counteract this, I have to, add 2 anti-dots, right? Because a dot and an anti-dot annihilate each other. But if I added 2 dots in the -i's, instead of adding 2 anti-dots, I could just add 2 dots in the i's box, right? If I add 2 i's and 2 -i's, I really didn't add anything. So this is still just a picture of 7. But now we see that we have the group of 1 dot next to 2 dots right there. Okay, and that's at the ones level because we're going in the counterclockwise direction. So all the dots must be in the first box. So therefore, we have one group at the ones level. And then, well, we see another here. We have 1 dot next to 2 dots right there. And we have another 1 dot next to 2 dots right there. Okay, so we have one group at the ones level and 2 groups at the i's level. But I guess it looks like I have 2 dots left over. So it looks like 7 divided by 1 minus 2i. Well, that looks like it's equal to, again, 1 plus 2i. 1 plus 2i with 2 dots left over, so plus a remainder of 2. Okay, and can we check that? Well, we can, right? Because if this is true, we know that then the quotient times the divisor plus the remainder must be equal to the dividend, or 7. So let's see, is that true? If we have 1 plus 2i, which is our quotient, times our divisor, which is 1 minus 2i, okay, and then plus the remainder, so plus 2. What is this equal to? Well, we have 1 times 1, which is 1. And then we have a minus 2i, 1 times minus 2i, it's minus 2i, and then plus 2i, that's 0. Then we have 2i times a minus 2i. So that's minus 4 times I squared. Minus 4 times I squared is a minus 1. That's minus 4 times a minus 1, which is plus 4. And then plus 2, that's indeed equal to 5 plus 2, which indeed equals 7. So yes, right, this is certainly a valid solution, but could we make the remainder smaller? And I think the answer to that is yes. Look at this picture. What do we want? We want 1 dot next to 2 dots going in the counterclockwise direction. And we have 2 dots here. So let's go ahead and put in 1 dot here. Then we have the 1 dot next to 2 dots. But I just added a dot in the i's box. So therefore, I have to add a dot in the negative i's box to counteract that. But then we have our group right here. 1 dot next to 2 dots at the i's level, but then I have the 1 left over at the negative i's level. So what is the answer now? Well, it looks like, again, we're doing 7 divided by 1 minus 2i, and now it looks like this is equal to, again, we still only have the 1 group at the 1's level, but now I have 3 groups at the i's level. So this is equal to 1 plus 3i, but now I have 1 left over in our negative i's box. So this would, I guess, be 1 plus 3i with a remainder of negative I. Is that correct? Well, if it is, then our quotient, 1 plus 3i, times our divisor of 1 minus 2i, plus our remainder, so plus a negative I, this should be equal to 7. Is it? Well, let's see. We have 1 times 1, which is 1. Then we have 1 times a negative 2i, that's minus 2i, and then plus 3i. So that's going to be what? A plus I. And then we have 3i times negative 2i. So 3 times negative 2 is a negative 6. I times I is I squared, which is negative 1. So negative 6 times a negative 1 is a plus 6. And then we have the plus a minus I. That's minus I. So 1 plus 6 is 7. Plus I minus I is indeed equal to 7. So yes, this checks as well. And we see that yes, we can make the remainder smaller in this case. And we can totally see it in our base I machine. Kind of cool.